Hello everyone. Yes, we had a lot of MatrixRTC talks, but I would like to do one more talk where I would like to share what I've been doing at Family and in my free time for the last 3 months or so, and what I think is one of the huge problems which we are slowly getting towards, and this is the key sharing problem. Quick intro about me because I have a lot to talk about. I'm TD. That is my socials. You can find it in some version of that on Fediverse, Matrix, etc. I work at Family and I do WebRTC and the TI Messenger stuff. Also, disclaimer, if you find something which is broken in this talk, please come to me after the talk. Do not ask it in questions. Please be responsible. Thank you. Also, I wanted to quickly go over how other providers do it first. So Jitsi uses Libel, which is the same thing which we do, but I should have written double ratchet, but Jitsi uses double ratchet, and they are currently limited to around 20 participants. They also have this ideology that if a key is shared too many times, it's not really a secret. So yeah, they limited to 20 participants. Zoom, of course, it gets its own special mention because it has its own little weird algorithm or protocol where they elect a leader and they decide to create a shared key with the participant. It does not use double ratchet or MLS. Yeah, you can read the white paper for more information about this. WebEx, Discord, Cloudflare, Wire, all of them use MLS, and we will get into this in one of my future slides. And of course, Google Meet and Microsoft Teams have really, really bad marketing. They have encrypted calls, they have end-to-end encrypted calls, and they have secure calls. You can go figure out which of them is the most encrypted version, but I believe that in their actual end-to-end encrypted version, they are also limited to around 50 participants or so. Now, what is the state of MatrixRTC with end-to-end encryption? Also, why do we even need end-to-end encryption in the first place? Because WebRTC has its own encryption, and it uses SRTP and DTLS. So as you can see in, does my mouse work? Ah, yes. So previously we used to have Alice and Bob connect directly, so these were the two peers, but now that we have introduced an SFU, the peer connection of the WebRTC is interrupted over here, and then it is recreated over here. And the SFU needs to know about the WebRTC packet because it needs to know where to actually route the packet. So what the S-frames RFC suggests is that you have your frame. This is what has your video data and your audio data. Then you put a secure frame on top of it, which is the S frame. Please ignore the packet part for now. The S frames RFC says that you can do it per frame or per packet, but we do it per frame because it is just more efficient that way. Once it is made into SRTP packets, then it still does the normal WebRTC stuff. At the SFU, we unlock the WebRTC lock, but we still have the secure frames lock inside. So the SFU cannot look at the data itself. It just looks at where to route the packet, and then it moves it forward. And then when the packet finally arrives at Bob, they have a key with which they can unlock the secure frames packet, and then they can look at the actual video. The S-frames RFC also tells us when to actually rotate the key and stuff, but it does not suggest what channel we need to use for the E2E key management. It of course suggests one, which is MLS, but we'll talk about this more. So now we move on to the key sharing part, and this is where most of the problems start. This, first of all, needs to be done in a secure channel. This is a little bit obvious, but if it's in the open, if you share the password to your streams in an open manner, then anybody can look at your streams. The current state of it is that it can be shared keys or per participant keys. Shared keys, unless if they are not done with a query parameters fashion, they are really hard to implement because you somehow need to talk between all the participants and decide shared keys. This leads to having elect a leader and stuff like Zoom does it, so we do not do that. That is difficult. Per participant keys are much easier. Every participant basically has their own key, and then they can decide who exactly to share it with, and it's point to point, super simple, easy to understand, intuitive. Also, you need to rotate your keys because you want forward secrecy and backward secrecy. So if someone leaves, and we assume that this participant has access to the infrastructure, they are recording all of the streams, then, well, they shouldn't be able to decrypt the streams once they have left. So you need to rotate your keys after someone leaves. You also need to rotate before when someone joins, because, well, they could have recorded the previous streams, and if you just give them the key now, then they can unlock all of the previous frames, which is not what we want. So rotate the keys as every time someone leaves or joins. But now you can see that this will create a burst. Say you have around 50 participants in a call, and one of them leaves, then you have to send 49 different messages about the key change. This can be sent using room events or two-device events, but there is a problem with room events, that room events are broadcast events, and you need to, so if you share the key in the room, everyone has an access to the timeline and everyone can decrypt it. So then you again have the problem that if someone is not in the call, but they are still in the room, then they can, well, have the key and they can just record all of the frames on the SFU, and then they can unlock the frames. That is not good. So what we want is, we want to share the keys only with the people who are actually in the call. And for this, we need to use two-device events, which uses OLM, and with OLM, you can actually pinpoint with whom to whom you want to send it. With room events, it uses MegaOLM, and it has a shared outbound session with which, well, basically everyone has access to the key, and you can't really create an outbound session with the participants in a call quickly, because that would basically use OLM, and yeah, then you might as well just use OLM. So what you want to do is you want to optimize this burst part. This is where most of the bugs arrive. I need to log in. Amazing. No, 1 second. That. Yes. So what optimizations can we do with key sharing? First, you want to debounce on leave. As you might have guessed, most people, a bunch of people leave and join the call at the same time. You do not want to start rotating the key as soon as someone joins or leaves. You want to debounce it. So when someone leaves, wait for around 4 seconds or so, then start rotating the key. You also want to give around 4 seconds or so that the key propagates. You don't want to start encrypting your new frames with the new key instantly, because then they don't have the key, and that will just not work. This will lead to another problem, which we'll get to in a second. Throttle on join. This is something new which we tried out, but it is really similar to debouncing on leave. What throttle on join does is, if you created a key 3 seconds ago, just use that key, it's fine. That does mean that you have around 3 seconds or 8 seconds on leave. This is the time frame where your frames can be decrypted by the person who just joined or left, but I think that is fine. Yep, that is mostly fine. Throttle on join has another problem. So for example, regarding the propagation delay, say you just joined a call, and now the other participants who are already in the call, they need to rotate the key and they send the key. But the participants in the call cannot send you the key which they have been using right now, because that would allow you to access the past streams. So you need to send them the latest key, but the senders have not started encrypting the streams with the latest key. So the participant who just joined waits for like 4 seconds or so, cannot see streams, because the streams are just not being encrypted by the latest key, and you cannot send them the old key, because then that would allow them to decrypt the past streams. So the S-frames RFC also suggests that you can use ratcheting on join. This is also a little bit finicky, but what it basically suggests is that instead of rotating the whole key on a join, you use some key derivation function, which is one way, and then the sender can rotate the key ahead. And once the receivers see that the frames are not decryptable, but they are still using the same key ID, then well, they try to rotate it forward, and then you see that, okay, now it works. So now we can save this version of the key for this key index, and you can use that one. But again, ratcheting is a little bit finicky, because if you go way too far ahead, then you cannot come back, because it is a one-way function. And in our implementation, at least, it was a little bit race condition prone, so we have disabled it for now. Also, I forgot to talk about the key ID and the frame part. The S-frames RFC also suggests how the frame should be formed. So, but it only suggests that. We don't really actually use this version. It suggests that we use the key ID and the initialization vector at the front of the frame, I believe. But in MatrixRTC, we just put it at the end of the field, and these are unencrypted. This is what Bob can see. Then it sees the key ID field in every frame of the packet, and then it uses that key to decrypt the key which corresponds to that key ID to decrypt that frame. It also suggests that we should have an authentication tag on the S frame, but we just don't do that for now. We just throw away all the frames which we could not decrypt, and That is not really good. Cryptographers would be mad at me because you really need authentication tag, and that means something. But yes, that is not a thing, but we can work on that. This one is a really simple one. You want to pre-share your key on the onboarding screen. Most group calls have a screen where they let you select the camera and the microphone. What you could do is just generate a key and share it already to the participants who are in the call, which means that as soon as you join, people can look at your stream, which is a really nice thing to have. Oh, and of course, there needs to be some retry mechanisms, but you need to rate limit it. So whenever you have an invalid key or a missing key, the crypto worker will tell you about this. And then you need to send a retry request, which is what we do with room events right now. And then the receiver of the retry request checks if the user is actually in the call and then sends them the key. But you want to make sure that this is rate limited, because if you keep spamming them with retry requests, then it is really easy to overload the receiver and the sender as well. And then finally, I would like to come to Family Call. This is one of the new projects which we have been working on at Family. It is a standalone app, and it is already integrated in the Family Messenger. You can think of it as the Element Call app. It has already been used by two of the largest university clinics in Germany, I believe, Charité and University Clinic of Munich, and they use it for their early born thingy, because children who are just born do not want to come to the hospital or something. We have managed to go around 50 participants with 720p streams, but I would like to point out over here that rendering 50 720p streams is not easy, and that is most likely the issue which we ran into here. And I will also show how we tested this, because it was not easy to test it. Yeah, but I believe that if we turn off the video and only check for audio, which is difficult to test again, we might be able to reach 80 to 100 people, but we haven't tested that yet. And of course, as you might have learned at the previous Family Talks, we are actively working into getting MLS into Matrix, and it is much more scalable. That's why most of the other providers like Cisco, Cloudflare, everyone else uses MLS, because you can really easily create scoped rooms in an existing room where you can share the key, and you do not have to create 49 different OM sessions to share it with the 49 different participants. So at some point, MLS will be a thing in Family Calls as well. I would quickly like to show you what my testing strategy was. This was a very expensive project where I had to get like multiple servers. All the participants in this screen used approximately 280 CPUs and 1.2 terabytes of RAM, because Selenium is super slow and buggy, and the Rust SDK is difficult to work with because it uses unsafe WebRTC, and it kept crashing when I wanted to use the end-to-end encryption features in the LifeKit Rust SDK. So what we basically did was start the Family Call app in a Selenium headless browser and throw it to servers, and then they just joined. And as you can see, testing for audio with this would be difficult because, well, I have no idea how I would implement that. So testing with video was just so much easier. There's one more feature. Does this work? Yes. I, of course, did the whole Family Call thing, but the most exciting feature was that I can add it in my calendar now, which means, like Microsoft Teams, I can have a Family Call link in my Google Calendar. It is a little bit slow because it creates the room and stuff, but yeah, it will work. Yes, there. And then you can join a Family Call from your Google Calendar. This was the most exciting feature I got to work on. But then I would like everyone to test the Family Call if you want to, because it's basically just going to look like this. And I will start taking questions already. I will share the link for the Family Call in the Lynn Conway room, so people can join who are online. They can also join. Wait, why is that so small? Oh well. No. Go. So I have 10 minutes left. Are there any questions? Oh, well, someone joined. I should mute myself. Hafi? Hello? Yeah, it is a call app like any other call app. But it has a bunch of optimizations which we use for the end-to-end encryption stuff, and we already use it at Family every day or so. And Anna?
Really cool demo. Have you thought about call recording yet?
Right. I tried to use the Rust SDK for that. But again, the end-to-end encryption stuff in the Rust SDK is still pending, I believe, so I could not use that. I would love to throw the Selenium thingy, but I have a feeling that Selenium and audio is not going to work. But I know that you tested it in Chrome. I have a feeling that Firefox would be better.
So yes, we tried to do it in Chrome such that we could get the UI recorded.
Nope.
But then we realized that actually it's quite heavy, especially if you have thousands of calls going on concurrently. So we ended up writing a Go library that allows you to consume and record both the video and audio streams and then upload them somewhere. So maybe we could collaborate on that because it's just the same tech.
Does the LiveKit Go client already support the end-to-end encryption stuff, or do I have to do that?
It does, but only for audio. We had to add it for video. But I mean,
it should be doable though.
Yeah, it's totally doable. Yeah, it's just not upstream.
Yep.
Thank you.
I have a feeling that Firefox would go better because with my demo as well, I tried Chrome first and it did not work well. But Firefox was just better for some reason.
I have one question.
Yes.
Just to be clear for myself. So it's a completely different implementation of MatrixRTC than Element Core, right?
It is the older implementation of MatrixRTC. Apparently, Element Call changed it, as you might have seen in the previous talk. And we haven't caught up to that implementation yet.
Okay.
But also, we are not sure if we want to completely follow that right now until it gets into the spec, because we have already deployed this with our customers and we do not want to break it. But yes, at some point, we would like to have it compatible with Element. Like, for example, 2 years ago at FOSDEM, we were already compatible. We showed Fluffy Chat and Element working together. So that is also on our to-do list.
Thanks.
So how does it compare to the Jitsi implementation of end-to-end encryption? As far as I know, they do the Rashid implementation of exchanging the keys.
The Jitsi implementation is super similar. They also use the double ratchet version, but they have manually limited it to 20 participants, while on Family Call we do around 40 or 50, but we do not manually limit it at the moment. Yep.
Okay, so it's manually limited. Okay.
Yes, to 20 participants.
Thanks.
Also, it uses Libol, which is currently deprecated. I'm not sure if they have any plans to move toward Osimac. No more questions?
No more question. Thank you, TD.
Thank you.